Okay, let's dive into something. Well, maybe a bit unexpected. Calculus.
In cow pastures.
Exactly. What do derivatives have to do with how fast a cow gains weight?
It sounds strange, but there's a really practical link there. It's quite insightful, actually.
Yeah, we've got an excerpt from a source that connects these dots. So, this deep dive, we're unpacking how this core calculus idea helps analyze something very real world.
Like cattle weight gain. Especially, when they're fed specific things like agricultural crop residues.
And if you're learning calculus, maybe grappling with differentiation, this shows you it's not just theory. It has legs, so to speak.
Definitely. It matters outside the classroom.
So the source talks about using derivatives for daily weight gain. Why focus on the rate, the speed of the gain, rather than just, how much weight they put on overall?
Well, because weight gain isn't just a steady climb. It's dynamic.
Okay.
It changes, right? Based on their age, what they're eating, their health, all sorts of things. A cow might start fast on one feed, then slow right down.
Ah, so just looking at the total gain over a few months would miss that nuance.
Completely. You miss the ups and downs, the critical points where things change.
And that's where derivatives step in.
That's the idea. A derivative, fundamentally, measures the instantaneous rate of change. How fast something is changing right now.
Okay.
So if you track a cow's weight, over time you've got data points. You can think of that as a function,
Right.
the derivative of that function. That tells you the exact growth rate in any specific moment.
Mm-hmm.
It's like the speedometer for their weight gain.
Okay, got it. So the source didn't just say, you could do this. It actually showed results, right? What did applying derivatives reveal, particularly with those residue feeds?
Yeah, that's where it got interesting. By analyzing the growth curve using derivatives, they could pinpoint quite precisely when cattle fed these residue diets hit their peak daily gain.
And compare that to cattle on more standard feeds.
Exactly. And they found differences. Well, the analysis showed that cattle on some of these residue mixes, they might start gaining a bit slower initially.
Okay.
But then they often sustained a pretty good growth rate for longer through the middle phase. So that peak gain, the fastest point of growth, actually happened later compared to animals on, say, higher energy feeds.
Huh. That's a concrete finding. So the total weight gain over 100 days might look similar,
Potentially, yeah.
but the pattern of how they gained it is different. How does knowing that help a farmer, practically speaking?
Oh, it's hugely practical. If you know the specific growth rate day to day or week to week and when that peak is likely to happen, you can make much smarter decisions. Optimize feeding, for one.
How so? Like changing the feed mix when the rate starts to drop off?
Precisely. Or adjusting the amount. Why keep pouring expensive feed into an animal if its growth rate, according to the derivative, is starting to plateau?
Right, makes sense. Saves money.
Saves money. Helps predict when they'll be ready for market more accurately. It can even flag potential health issues. If an animal's gain rate suddenly tanks, the derivative shows that sharp drop instantly. Way faster than just noticing they look a bit thinner after a week or two.
So it moves beyond just averages and guesswork.
Definitely. It's more like data-driven dynamic management. Especially useful for feeds like crop residues, where the quality might vary a bit.
You can really quantify how those small feed variations affect the actual growth efficiency over time.
That's the power of it. It gives you a much clearer picture of the biological response.
So let's wrap this up. The takeaway seems pretty clear. Derivatives aren't just abstract math problems.
Not at all.
They're practical tools. They let us analyze rates of change, how fast things happen in the real world, whether that's chemistry, data flow,
Or how fast a cow is putting on weight based on its diet, like those agricultural residues our source looked at.
And hopefully seeing this application, seeing differentiation used for something so tangible, helps make the concept click if you're studying it.
Yeah, it makes it less theoretical, more grounded.
Definitely. And maybe it leaves you with a final thought. If calculus can give us these kinds of specific insights into optimizing cattle growth, well, what else is out there?
What other everyday things? Things that seem totally unrelated to math.
Right. What else could be understood better, maybe even optimized by applying these kinds of mathematical tools? Something to keep an eye out for the math hiding in plain sight.